finding the greatest common factor is basically just finding the largest factor that two or more multiples have in common. I listed two multiples on the board, 81 and 27, and I'm going to walk you through how to find the greatest common factor between the two multiples, 81 and 27. Now, remember in class we did a Venn diagram and first started with the factor tree, which is an extenuation of the prime factorization. So we're going to basically find the prime factorization for each of the two multiples, and then find what they have in common from there using a Venn diagram. So to begin, I color-coded the numbers 81 and 27. 81 is in green, so I'm going to break down that tree using green and a green circle when I draw the Venn diagram. And 27 I'm going to break down using blue and draw a blue circle that overlaps the green one when I draw the Venn diagram. So to begin, 81 is a composite number that can be decomposed or broken down. And two factors that make 81 would be 9 and 9. So I'm going to use 9 times 9. And then I have to decide if 9 is composite or is it prime. And 9 is composite because it has two or more factors. 1, 9, and 3 are all numbers that make 9. So I'm going to break 9 down, decompose 9. And 3 times 3 makes 9. So I'm going to put 3 times 3. And then I'm going to decide if these numbers are prime or composite. Well, 3's are prime numbers, so I'm going to circle them. And I'm just going to circle them in black. And then I'm going to decompose that 9 and break it down. And once again, the 3's are prime, so I'm going to circle them to show that they cannot be further decomposed. Now, since all of these numbers are prime and can't be further broken down, I am done. So basically, the prime factorization for 81 is 3 times 3 times 3 times 3. And I'm going to need those 3's in a second, but I'm just going to leave them there for now. Next is 27, and we have to decompose 27. 27 is composite because there are 4 factors that make 27. So it has at least two or more factors that make 27 other than 1 in itself. So I'm going to use 9 times 3 to make 27. And then I'm just going to decide if each one of those factors are prime or composite. 9 is a composite number, so I'm going to decompose 9. And 3 times 3 makes 9. Oops. I need blue because I'm color-coded. So 3 times 3 makes 9, and then I'm going to decide if those numbers need to be circled or further decomposed or broken down. 3 is prime because the only way to get 3 is 1 times itself, so I'm going to circle it. And that means I'm going to circle all the 3's. There's no other numbers waiting to be broken down, and so I'm done. All the numbers that are underneath the branches are circled, which means they're prime and can't be further broken down. So the prime factorization for 27 can be written as 3 times 3 times 3. Now this is where I draw the Venn diagram, and just because I don't have that much space, I'm going to try to fit it right in here. So I'm going to draw a green circle indicating where I'm going to put my prime factorization for 81. And a blue circle that overlaps the green circle to show where I'm going to put my prime factorization for 27. Well, 27 was 3 3's, so I'm going to write 3 3's in there. And 81 was 4 3's. 1, 2, 3, 4. So I'm going to put my 4 3's right here in the green portion of the circle. Then I'm going to figure out what they have in common. What numbers are in common. So what green number can match up with the blue number. And if there's a green and a blue of the same number, I'm going to move that number to the middle to represent that it is in common. And right here is that space that represents that the numbers are in common. So I have a green 3 and a blue 3. So that 3 can go in the middle. That's in common. I have another green 3 and another blue 3. That 3 can also go in the middle to show that's in common. And then I have another 3, green 3, and another blue 3 to show that they're in common. I put that 1 3 in the middle. Now, I'm not writing the 3 twice. I'm writing the 3 one time because it's in common between the two circles. So that's why I crossed out a green with a blue and wrote it once. Not twice, but wrote it once because it's in common. It's in both circles. So I move it to the middle portion of the circle to show that it's in common. Now, anything that's in common in the middle portion of the circle, the overlapping portion of the circle, gets multiplied together. So I'm going to be multiplying 3 times 3 times 3, and that will give me my GCF. 3 times 3 times 3 equals 27. So 27 is the greatest common factor between 81 and 27.